take a look at question number 50. We're also asked to solve this one by using the quadratic formula. Notice we already have one side set equal to 0, so we can identify our coefficients. A is 1, B is negative 6, and C is positive 34. We're going to take those and plug them into the quadratic formula. It's x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So it's going to be the negative of negative 6 plus or minus the square root of negative 6 squared minus 4 times a times c, all divided by 2 times 1. Negative of negative 6 is going to give us a positive 6, plus or minus the square root of negative 6 squared is a positive 36. Negative 4 times 1 times 34 is a negative 136, all divided by 2 times 1, which is 2. We have 6 plus or minus the square root of negative 100 over 2. And now, first of all, because we have that negative inside of a square root, that's going to come out as the imaginary unit I, and then the square root of 100 would be just 10. So we get 6 plus or minus 10i divided by 2, and then both terms in the numerator are divisible by 2, so we get 3 plus or minus 5i. So those are our two solutions. One is 3 minus 5i, the other is 3 plus 5i. In question 51, they ask us to solve the quadratic equation using whatever method we prefer. We already have one side set equal to 0, which is good. And typically, if you're able to factor these, generally factoring is a little bit faster than any other approach. If you don't see how this factors, you can still use the quadratic formula. But I'm going to go ahead and factor this. This will factor as 4x and x, 3 and 1, and the sign should be a minus and a plus. If you have it factored, you can just set each factor equal to 0 individually, and then solve each of those equations. For this one, you would subtract 1 from both sides. We would get 4x equals to negative 1, divide by 4, divide by 4. So one solution is x equals negative 1/4. Here we would add 3, so our other solution would be x equals to positive 3.